Hello and welcome to Honors Function. In this second lecture on complex numbers, we're going to be exploring the use of complex number when it comes to solving equation. There are no results in this lecture, no theorem, no definition. It's just an application of complex number and their operations. So let's start with the first example. All right. In this first example, we want to simplify the product of these roots. Now you can see the square roots, they are not real, square root of negative number. How do we do that? Well, let's take square root of negative 6 times square root of negative 15, and this is what you cannot do. Don't say this is the same thing as square root of negative 6 times negative 15, because this is wrong. Okay, when you have studied these properties, sorry, a B right there, when you have studied this property, it was stated somewhere, students usually don't pay attention to it, that everything had to be a real number. Okay, everything had to be a real number. Well, this is not the real number, therefore this property is not true. And we're gonna see why it's not true, right? If you were to do this operation right here, if this was allowed, you could write this as the square root of 6 times 15, right? And this simplifies to what? 6 is 2, 3, 15 is 3, 5. So it would be 3 square root of 10, right? I keep these two inside. Well, this is not at all what this product is going to be equal to, right? So how do we do it? Well, negative 6 is the same thing as I squared times 6, and negative 15 is the same thing as I squared times 15, right? Because I squared equals negative 1. Now, square root of I squared is just I, okay? So this is I root 6 times I root 15, which is I squared, so it's negative, and this is the square root of, I just went over it, so I can take a 3 out, 3 root 10, okay? So it's negative 3 root 10, all right? I'm gonna let you do number 2, I'm gonna do number 3. So, let's apply the property about the square of a sum. So this is root of negative 3 squared plus 2 times root of negative 3 times root of negative 5 times root of negative 5, plus root of negative 5 squared. So this is negative 3 plus, okay, so what is this? This is 2 times I root 3 times I root 5, right? Plus negative 5. Okay. So it is negative 3 and negative 5, that's negative 8. And here we have I times I squared negative I, minus 2 square root of 15. Okay? Negative 8 minus 2 square root of 15. Actually, by the end of these notes, I'm going to show you how to use my calculator. Actually, this is what I have in my notes, but I'm going to do it right here. Why not? Let's do this using the calculator. Although we have a root of 15, that's not very pretty here. Here, this is what we can do. Check it out. It's kind of interesting, actually. Look. All right, so this is a calculator. Where do you have complex number? If you need I, it's the second dot right here. This is I right there. But let me see when I enter square root of negative 15. What do I have? Enter. Okay, it says real mode. So I need to change my mode. I don't want to be in real mode. So let's change the mode. So quit, first of all. And then let's change the mode. And let's go to complex mode. So where's my complex mode? I guess right here, A plus IB, right? So down, 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 A plus IB selected, enter. All right, quit. Let's go back to the home screen and let's do that again. Second, enter. And here we go. I have my number, right? This is I. Now, if you have something like that, you don't know what it is, right? Because you can do a math frac and that is not going to work. Math frac and nothing works, right? Because it's not a fraction. This is square root of 15. How do you know? If you have the intuition this is root of 15, how can you find it? Well, that's easy. Just divide by square root of 15, and that should just be I. Yep, that is actually the square root of 15 because I have 1 left, okay? Anyway, let's see what we have now that we have the right mode when we do the operation. So it is square root of negative 3 plus square root of negative 5 squared. All right, let's see that. So we have square root of negative 3 plus square root of negative 5. Let's close the parentheses. Let's square that. And that is negative 15.745. Well, I'm not sure what that is. So let me see what my answer is. I think it's negative 8 minus 2. So I could type that in the calculator and check it out, right? It's going to be as easy. So let's see. Negative 8 minus 2 square root of 15. Let's see if this is what we have. And yes, that's what I have. So I got it. I have the right answer. All right, you see, pretty simple. You just got to change the mode and make sure you are in the A plus IB mode. Let's move on with more example. So these were just square root of negative numbers. Now, let's solve some equations with complex number. So for example, here's the first equation right here. Actually, you know what? I'm going to let you do this one. Please do number 4. I'm going to do number 5. And by doing number 5, you will have a little bit of number 4 there. All right, I'm going to do number 5. Number 5 is based on a formula that I'm not sure a lot of you remember. I'm going to remind you of this formula as soon as we start polynomials. But right now, let's quickly recall it. It's a difference of cube formula. This is a difference of cube. I know you all know how to factor a difference of squared, right? This is a plus b times, actually, let me start with a minus b. This is a minus b and times a plus b, right? Okay. The difference of cubes starts in the same way, a minus b, but then inside you have a squared plus ab plus b squared. How do you check it out? Hey, just expand this and you will see it's a cube minus b cube. Here, while we're at it, let's recall the sum of cube. You should have seen that in Algebra 2, okay? No matter what Algebra 2 level you're taking, regular honors, this is normally in the program, right? So here, it's a plus b times what? Times a squared minus ab plus b squared, okay? So this is a quick recall of these formula. Let's see how they apply to solve this equation now. All right, so what do we have? I have a difference right here of cube, right? This is a difference of cube. It's x cubed minus 1 cubed, right? Okay, so I'm going to apply my difference of cube formula. So I have x minus 1 times x squared plus x plus 1 equals 0. Now, if you don't make a mistake, this part right here never factors. It's always prime if you haven't made a mistake and if you have factored everything before, okay? So don't even try to factor this. It will not factor right here, right? So let's solve this equation. So we have x minus 1 equal to 0, which of course gives us x equals 1. Well, duh, okay? If x cubed is equal to 1, we know that x equals 1 is one of the solution. But we have two more, or x squared plus x plus 1 equal to 0. Now, of course, these are not going to be real solution. So I'm going to complete my square because I just like it. So this is plus 1/2 squared minus 1/4 plus 1 equals 0. So we have x plus 1/2 squared. Now on this side, this is plus 1/4, so minus 3, this is plus 3/4 right here, right? So if you move it on the other side, it's minus 3/4. And so the other solution is x equals, so right here, you take plus or minus square root, right? Plus, okay, I'll write it, negative 1/2 plus or minus square root of negative 3/4. You can't leave it like that, of course. The negative sign goes out as I, so it is negative 1/2 plus or minus I square root of 3/4. We really should go one step further. Negative 1/2 plus or minus I root 3 over 2. That's it. These are the other two solutions, and they are complex. Okay, so this equation has 3 solutions in the set of complex number. Please do number 6. You're gonna need this formula for number 6. Okay, let me move on. I'm going to start number 7, but I would like you to finish it. So what do we have here? We have x4 minus 16, which is the same as x2 minus 4 times x2 plus 4. So I know you can all solve this. That's easy. It's all real. Do not forget to solve this equation. x2 plus 4 equals 0. You can all solve it, and this is going to be in C. Okay, so the solution here will be in R, while right here the solution will be in C. It's pretty simple to solve that. Okay, now these equations that we just solved all had real coefficients, right? Let's solve some equation now with complex coefficients. So here's the first one. Actually, I'm going to let you do number 8 because it's easier than number 9. So I'm going to let you do number 8, and I'm going to tackle number 9. Okay? Now this number 9 is a quadratic equation. Okay? It's a quadratic equation in Z. This is a complex number. What's A? A is 2 minus I. What's B? B is negative 1 plus I. And what's C? It's 1 minus 2i. Okay, let's solve this equation using the quadratic formula. So we have Z equals negative B, so 1 plus I, plus or minus square root of B squared. So B squared, so I don't care about the negative sign, right? It's going to go. So it's 1 plus I squared, which is 1 plus 2I plus I squared minus 1, right? Plus I squared minus 1. 1 minus 1, so it's just 2I. So I have 2I right here, minus 4 times A times C. Okay, let me do A times C right here. So I have 2 minus I times 1 minus 2I. Here, how about we take the calculator? I want to show you. Check it out. So, oops, let's go right here. So I'm going to do 2 minus I. Right here, I is right here, second dot, times, and I forgot what it was, 2 minus I, times 1 minus 2I, times 1 minus 2, you will see it's kind of really nice, 2I, here we go, let's close it, and let's just enter, negative 5I, beautiful, negative 5I, here we go, so minus 4 times negative 5I, right, I think, so we over what? Over 2a, so over 2 times 2 minus I. Oh, this is not pretty, right? So it is 1 plus I plus or minus, so square root of 22I divided by 2 times 2 minus I. These are my solution. Of course, I have to change it, okay? The first thing I need to do right here is rewrite this. So let's work on this. The square root of 22I, this is the square root of 22 times the square root of I. And the square root of I, guys, this is from the previous lesson. This is the principal square root of I. If you check out in lecture 30, whatever it was, 33 I think, or 32, it is 33. It is 1/2 plus 1/2, no, sorry, 1 over root 2 plus 1 over root 2I. Okay, it's a problem I did, and you had to figure out square root of negative I think. Okay, so I did this problem right here. So this is root of 22 times 1 over root 2 plus 1 over root 2I. Okay, so let's simplify this. So it's root 11 plus root 11I. Alright, so what can we do here? We can factor root 11, right? So it's root 11 times 1 plus I. Okay, that is kind of nice right here. So let's plug it back in this solution right here. So we have 1 plus I plus or minus root 11 times 1 plus I. Of course, we're going to factor 1 plus I over 2 times 2 minus I. Okay, let's factor 1 plus I. So it is 1 plus I times 1 plus or minus root 11 divided by 2 times 2 minus I. Okay, we are almost there. I just need to get rid of this I at the denominator, and I just know what to do. I'm going to multiply by 2 plus I, of course. Okay, 2 plus I right here. Alright, so at the top I'm gonna take care of this product right here. 1 plus I times 2 plus I, and I'm gonna ask my calculator. 1 plus I times 2 plus I, and this is 1 plus 3I. Alright, so we have 1 plus 3I times 1 plus or minus root 11 over, and here we have these 2 times, and here a squared plus b squared, so 4 plus 1 right here. Wow, okay, this is really messy. So what's going on here? This is 5, this is 10. So I believe we have 1 plus or minus root 11 over 10 times 1 plus 3I. I think these are my two solutions right here, right? I think these are my two solutions. Alright, well, this is really not that pretty. What can we do to check if this is or not the solution to our equation? I really don't want to have to plug it into the equation, especially given the fact that my coefficients are all complex. That would be really a bad idea, right? So let's use a calculator to speed up this checking. Here's what I'm going to do. I'm going to store actually these three coefficients into my calculator. So let's start with that. So let me take my calculator. Okay, so now let's store 2 minus I is right on top of the dot right here. 2 minus I. Let's store that into A right here. Okay. Let's store negative 1 minus I into B, like that, right here, negative 1 minus I into B. And finally, let's store 1 minus 2I, 1 minus 2I into C. Okay, here we go. 1 minus 2I into C. Now, I'm going to take my solution right here, and I'm going to store that in a letter right there. We'll see what. So let's see, it's and I'll take the plus. Okay, I'm gonna start with the plus. 1 plus square root of 11 over 10 times 1 plus 3I. So let's do that. I need to open the parentheses, of course. 1 plus square root of 11 divided by 10 times, and this is I think it's 1 plus 3I, right? 1 plus 3I right here, 1 plus 3I, and I'm going to store that in, I don't know, here, let's try D. Okay, yeah, I haven't used D, like that. Okay, here we go. So my solution is stored in D, and what I'm gonna do now, I'm just gonna type my equation. So I have A times my solution square, D squared, plus B times my solution, and then plus C. And let's see if we have 0 or not. And that surely doesn't look like 0 to me. So does that mean I make them... Oh, look at this right here. Yeah. Okay. Okay, at least I don't have to retype everything. I made a mistake in the way I entered this, right? So let me go. I forgot to open... how do I... Right here. I forgot to close the parentheses after. square root of 11. So get out of the root, insert, this is really, I cut this one, but it could have been terrible, right? Okay, here we go. All right, now let me grab my equation again, so I can just grab it. If you don't have a calculator like that, you should do second enter, right? You can do second enter. I'll show you. And yes, yes, great. We have the solution. Here, let me show you what I mean by second enter. I'm gonna check the one with a minus now. So second enter. That's not what I want. Do it one more time. Second enter. And that's what I want. I'm gonna go on. So you see, this is what you do when you don't have this kind of calculator, right? When you have an older model. It's okay if you have a TI-83. You can still grab some previous entry, prior entry. Let's push enter with the minus. Let's do second enter to grab the equation. That's not my equation. I'm gonna do it one more time, and I'm gonna push enter, and I got it, and it works. I have both solutions. All right. Well, the end of the video was just to show you what to do with complex number. Here, I'm going to show you one last thing. Let's take, for example, 1 plus I divided by 2 plus 3I right here. So we know what to do. This is not easy even without the calculator, but I'm going to show you with the calculator. You see these? I'm pretty sure, I know actually that I don't have any irrational number, so you can turn that into a fraction. Math, frac, and enter. And look at this. This is very, very nifty. All right, and this will conclude this video. Thank you for watching.